Welcome to CBC Training Module 2, Building Types. In this module, we will explore different types of pre-engineered metal buildings, their key structural components, and their applications. Module, you will understand different types of pre-engineered metal buildings, learn the key structural components and their applications, be able to explain the advantages and use cases for each building type. Pre-engineered metal buildings, or PEMs, are factory-fabricated and standardized building systems. They provide an efficient, durable, and cost-effective alternative to traditional construction. These structures are used in various industries for many different applications. Some common uses include warehouses and storage facilities, manufacturing plants, retail and commercial buildings, aircraft hangars and truck terminals, agricultural and farm structures. Now let's explore the different types of metal buildings used in these industries. The first type of building we will discuss is the clear span building. A clear span building combines the proven strength of a rigid frame with exceptional size flexibility. These structures maximize interior space, making them ideal for manufacturing plants, warehouses, offices, and retail stores, where uninterrupted open areas are essential. Beyond the interior, size flexibility also plays a key role in optimizing land use, ensuring efficient site planning. Inside a clear span building, you have near total flexibility to customize the height, width, and roof slope to meet specific project requirements. Clear span buildings are designed with no interior columns. This allows for maximum open space, making them ideal for large equipment, storage, or work areas. Key features include widths ranging from 20 to 150 feet, eave heights between 10 and 30 feet, roof slopes between 0.25 on 12 and 4 on 12. Available in tapered or straight columns, can be expanded using lean-to structures. Now let's explore the advantages and considerations of clear span buildings. Let's take a moment to review the advantages and considerations of clear span buildings. Advantages: clear span structures offer no interior obstructions, making them ideal for large equipment, storage areas, or open workspaces. They also provide flexible design options, allowing for adjustments in height, width, and roof slope to meet project-specific needs. And with future expansion in mind, clear span buildings can easily integrate lean-to additions, giving you room to grow. Considerations: however, they may not be the most cost-effective solution for extra-large buildings. Wider spans often require heavier framing, which can increase material costs. Up next, we'll take a closer look at multi-span buildings, a great option for larger projects where cost efficiency is key. Multi-span buildings use interior columns to provide additional structural support, making them cost-effective for large-scale structures. Key features include widths from 40 to 500 feet, eave heights from 10 to 30 feet, interior column spacing of 20 to 100 feet, supports up to 8 interior modules, available in straight or tapered columns. These buildings are ideal for industrial projects, truck terminals, and warehouses that require high capacity and flexibility. Now let's look at the advantages of multi-span buildings. They are more cost-effective for large buildings than clear-span buildings, provide greater size flexibility. Multi-span buildings can support heavy loads, cranes, and additional equipment. Here are some considerations when considering a multi-span building. First, interior columns reduce open floor space. And second, multi-span buildings are not ideal for applications requiring uninterrupted space. If maximizing interior space is a priority, clear span buildings may be a better choice. Next, let's talk about lean-to buildings. Lean-to buildings provide a cost-effective way to expand existing structures without constructing a separate building. Key features include widths from 8 to 60 feet, eave heights from 8 to 30 feet, roof slopes between 0.25 on 12 and 4 on 12. Lean-tos are attached at or below the eave of the main building. Lean-to buildings are commonly used for storage areas, covered workspaces, or as additional facility expansions. End walls provide structural support and determine future expansion capabilities. We offer 3 types of end wall types. The first type is the bearing frame. The bearing frame is the most cost-effective, but not expandable. The second end wall type is the expandable main frame. This frame is designed for future expansion. The third type of end wall frame we offer is the non-expandable main frame. This frame provides structural support but cannot be extended for future TE expansions. Choosing the right end wall type affects cost, expansion options, and structural integrity. The bearing frame end wall is lighter in design and weight than the main frame end wall because it only supports the roof load of one half of a bay. The end wall columns support the channel rafter and also serve as columns for attachment of the end wall girts and transmit wind load into the foundation and structural system. Bearing frame end walls also require a form of bracing, whether it be X-bracing, portal frames, or diaphragm action. The benefit of having a portion of the building with an unobstructed floor area while maintaining the cost savings of a multi-span building. The use of a bearing frame end wall is a matter of economy. You will usually find the prices of the bearing frame end walls are much more economical than the expandable main frame end walls. The expandable main frame end wall is used where wall structurals and covering panels are required. Since the expandable main frame is designed to accept a full bay loading, it may be used for ease in any future expansion. The key characteristics of an expandable frame are, they are designed to carry an additional bay's load. Using this frame allows for seamless future expansion. Expandable frames are built with heavier steel components for added strength. The expandable main frame end wall is a combination of the standard main frame with end wall columns. The end wall columns do not support, but serve only as columns for attachment of end wall girts and transmit the wind load into the foundation and structural frame. The expandable main frame's largest advantage is that it provides for easy expansion. Since it is a main frame, it will carry the design load of a full bay, and it can remain in place if the building is expanded. The non-expandable main frame end wall is still a main frame with end wall columns, but cannot be used for future expansion. The non-expandable frame can only carry the design load of one half bay. Both the expandable and non-expandable main frame end walls provide for more flexibility and ease in locating large framed openings or entrance doors. Locate the openings by simply adjusting the end wall column spacing. Also, the main frame end walls do not require any form of bracing, therefore X-bracing or portal frames will not interfere with large openings. The characteristics of the non-expandable frame are as follows. They provide additional structural support. They are not intended for future expansion. They are lighter than an expandable frame. They can be used for buildings with large doorways or heavy loads. When it comes to selecting the right end wall frame, it's important to consider your project priorities. Let's break it down. First, choose a bearing frame if cost is the main factor and expansion isn't needed. This is the most economical option, ideal for fixed-size buildings. Second, choose an expandable frame if there's a possibility of future additions. This frame is engineered to support extra loads, making expansion seamless down the road. Third, choose a non-expandable frame if your project requires additional strength, such as for heavy loads or large openings. While it doesn't support expansion, it offers the reinforcement needed for more demanding applications. Each frame type has its purpose, so choose the one that best fits the current and future needs of your project. Let's take a moment to recap what you've learned. Clear span buildings, best for applications that require maximum open space without interior columns. Multi-span buildings, a more cost-effective solution for large-scale structures using interior supports to span wider areas. Lean-to buildings, ideal for expansions and storage, offering a simple and affordable way to add extra space. End wall types, choosing the right frame, bearing, expandable, or non-expandable, can impact cost, structural strength, and expansion potential. Understanding these building types gives you the ability to confidently recommend the right structure for any project. This section introduced the various building types offered in CBC's standard product line, each designed with flexibility, strength, and functionality in mind. Clear span buildings are ideal when maximum interior space is needed, with no interior columns making them perfect for manufacturing, warehousing, and retail environments. In contrast, multi-span buildings use interior columns to support wider building widths, extending from 150 feet up to 500 feet, making them a cost-effective option for large-scale structures. Both clear span and multi-span designs are available in gable symmetrical, a rigid, double-slope roof with the ridge centered; gable unsymmetrical, a double-slope roof where the ridge is off-center; single slope, a roof that slopes in one direction from one sidewall to the other. Each of these structures can also be designed to support a lean-to, ideal for adding extra covered space alongside an existing building. These building types form the core of CBC's product line, recognized throughout the industry for their proven quality, cost-effectiveness, ease of assembly, and versatile design options. They represent a key revenue opportunity for you and your business. Now let's test our knowledge of CBC's building types. Now that you've completed the core content of Module 2, it's time to put your knowledge to the test. This quick review will reinforce the key concepts we've covered: building types, their structural differences, and how to match the right solution to your customer's needs. Take a moment to reflect on what you've learned, and when you're ready, let's test your knowledge of CBC's building types. What type of building allows for the maximum use of uninterrupted interior space? A. Multi-span building. B. A building with interior columns. C. Lean-to. D. Clear span building. E. None of the above. The correct answer is D. Clear span building. Clear span buildings are specifically designed without interior columns, making them the best option when open, unobstructed floor space is required. They're ideal for warehouses, manufacturing plants, and retail environments where maximum usable space is critical. In contrast, multi-span buildings and buildings with interior columns divide up the interior, and lean-tos are typically used as secondary additions, not for primary open space. Question 2. Clear span buildings with tapered columns are limited to 180 feet as a standard. A. True. B. False. The correct answer is B. False. While clear span buildings offer impressive flexibility, the standard maximum width for tapered column designs is 150 feet. Widths beyond that may require special engineering or structural modifications. It's important to keep this in mind when planning or quoting large span structures. Question 3. Clear span frames with straight columns lend to economy when the span is between how many feet compared to a tapered column? A. 60 to 100 feet. B. 90 to 110 feet. C. 60 to 80 feet. D. 100 to 150 feet. E. 150 to 200 feet. The correct answer is C. 60 to 80 feet. When your clear span building falls within this range, straight column frames often provide a more cost-effective option than tapered columns. They maintain structural integrity while reducing complexity and material costs within that specific span range. Question 4. A multi-span building with 3 interior columns will have how many modules? A. 1B, 3C, 2D, 5E, 4. The correct answer is E. 4. In multi-span construction, each space between columns is considered a module. So, with 3 interior columns, you create 4 distinct modules, 1 between each pair of columns and 1 on either end. This modular breakdown is key to understanding load distribution and interior layout planning in large metal buildings. Question 5. The most economical end wall is A. Expandable mainframe. B. Bearing frame. C. Non-expandable mainframe. The correct answer is B. Bearing frame. When we're not considering building width, column spacing, or loading requirements, the bearing frame end wall is the most cost-effective option. It uses lighter materials and is engineered to support only half of the adjacent bay's load, which helps reduce fabrication and installation costs. This makes it an ideal choice for projects where future expansion isn't planned and budget is a top priority. Question 6. Which type of building is not a self-supporting structure? A. Single slope. B. Gable unsymmetrical. C. Gable symmetrical. D. Lean-to. The correct answer is D. Lean-to. A lean-to structure relies on an adjacent main building for support. It's designed to attach to the side of another structure and cannot stand on its own. In contrast, single slope and gable-style buildings, whether symmetrical or unsymmetrical, are self-supporting, standalone structures. Lean-tos are an excellent way to add extra covered space, but they require a primary frame to anchor to. Question 7. When a lean-to does not extend the full length of the main building and begins or ends at an interior main frame, a bearing frame end wall is the standard condition on the lean-to. However, a main frame end wall could be used if necessary. A. True. B. False. The correct answer is A. True. In this situation, a bearing frame end wall is typically used on the lean-to because it provides adequate support when it starts or ends at an interior main frame of the primary building. However, if the project requires additional strength or future flexibility, a main frame end wall can be used as an alternate solution. This design approach balances cost-effectiveness with engineering flexibility, depending on the structure's purpose and load requirements. Question 8. Is it imperative that the base spacing of a lean-to equal the base spacing of the supporting structure? A. Yes. B. No. The correct answer is A. Yes. For a lean-to properly align and connect to the main building, the base spacing must match the base spacing of the supporting structure. This ensures proper load transfer, structural stability, and alignment of the framing elements. Mismatched base spacing can lead to engineering issues, erection challenges, and potential structural compromises. So yes, it is imperative that the base spacing be consistent between the lean-to and the main frame. This concludes our review of Module 2, Building Types. In this module, we covered the core building styles used in pre-engineered metal construction, including clear-span, multi-span, and lean-to buildings, as well as the different end-wall frame types and their applications. If you have any questions or need additional support, please don't hesitate to reach out using the contact information provided on this slide. Great job completing this module, and we look forward to seeing you as you move forward to the next step in your training.